Okay, welcome everyone. Before we start, I will just give it one more minute to allow people to trickle in. Okay, we will go ahead and get started. My name is Megan Gallagher. I'm on the Green Building Committee. As always, feel free to drop your questions in the chat window and we will make sure to answer them at the end. Today, I have the pleasure of introducing a colleague of mine to talk about a growing trend in new and existing homes. Batteries, much like solar panels, have advanced technologically at a rapid pace and are becoming more affordable every day. While they do still cost a pretty penny, homeowners want the assurance of some level of backup power in the event of losing power from the grid. Chris Olafson will discuss the different applications for batteries that are coupled with a PV solar system and how they can be advantageous for homeowners. Chris, take it away.
Excellent. Thank you very much, Megan, for the introduction. Thank you for the invite as well. Rochester area builders, specifically you guys here on the Green Building Committee, thanks for having me to talk about solar, talk about batteries, and all things related to both of those topics. So I'm going to get started here in just a second, kind of a brief overview of kind of how this is going to go. We're going to start off just kind of talking about solar itself, basically grid-tied solar, which is what we do here primarily at Solar Connection. So we'll talk a little bit about industry trends, what's going on in Minnesota, what we're seeing as one of the local installers of solar here in southeast Minnesota, and then we'll kind of get into the battery conversation kind of middle of the way through the presentation and towards the end as well. So if you wanted to put questions in the chat feature, Megan will be fielding those, and I'll try and answer those as we go to the best of my ability, but certainly there'll be plenty of time here at the very end for you to ask questions about any of the topics that we're going to cover here. So let's kick it off. So like I said, to start out, I just kind of wanted to show a couple of things to really reiterate how much solar has really grown, specifically in our area, and I guess Minnesota at large in the last, I don't even know, maybe 5 years or so. It's really taken off at a tremendous pace, which is to be expected when you have some of the incentives and the favorable policies at the state level that we have here in Minnesota. And I'll talk about that a little bit more once we get into the battery discussion. But the map that you see here, this was a recent compilation of all of the systems that we've done in Rochester specifically. So with a zip code that matches up with Rochester, and you're seeing 155 home and business owners, some farm owners as well, that have worked with us to have a solar energy system installed on their property. So this first one here is, like I said, just Rochester. That includes RPU customers as well as People's Electric Co-op customers that are outside of the city limits. We work with them and many other utilities across the southeast Minnesota and western Wisconsin markets. This image here is not a comprehensive map, but is a map of some of the other installations that we've done in the last, I'd say about 5 years or so. So you can kind of see our service territory. We definitely are going, you know, as far as we really feel comfortable going to help people realize their renewable energy goals. We do get up into the Twin Cities occasionally, not super often, just because there's a lot of other companies up there that are taking care of those folks. But you can see that solar is not necessarily just something for people that live in town. It's not something just for people that live out of town or on a farm. It can really work for everybody. And our goal here, at least in the sales department, which is where I work, is to take people through a process that helps them determine whether or not solar is right for them. So it certainly isn't right for everybody. We unfortunately have to tell lots of folks that live in Rochester here in the Pill Hill neighborhood, where there's lots of really mature trees, lots of older homes that have some interesting roof layouts and angles and different things that play a factor in this. So that's really our goal when meeting with people and figuring out what their goals are, what they would expect something like this to do for them. Are they interested in the environmental aspect of it, or are they just looking for a good financial return and avoiding the kind of constantly escalating prices of energy that they've been seeing over the years? And so, as you can see here from this map, we are very, very busy. We're working with lots of people. We've got a good list of people signed up to do installations with us already this upcoming construction season, starting hopefully sometime in the next month or two. We'll be able to get back out and get going on some of these projects. So that hopefully kind of speaks to how popular this is. And if you do any amount of driving around in our area, you've probably seen lots of solar, so it more than likely doesn't really surprise anybody, I wouldn't think, of how popular this has really become in the last 5 years or so. So here is just a graph from one of the industry associations that most solar companies use as kind of a benchmark, Solar Energy Industries Association, or SEIA. They are a US level industry association that gathers information and data from all the different states to basically figure out how much solar is getting put in. So as you can see from the last 10 years, you know, hardly even legible how much solar was getting put in 2010. You know, moderate increases from 2010 till about 2015, and then in 2016 is when we really saw a boom here in Minnesota, specifically on the utility scale and non-residential, which is farms, commercial businesses, those types of systems. So the big fields that you see out in the rural parts of the state, specifically, you know, west of us here in Rochester and Dodge County, there's lots of them, several of them along the 52 corridor between us and the Twin Cities as well. And you can see the amount of capacity measured in megawatts is pretty tremendous when you start aggregating all of the larger systems in there. We're primarily here at Solar Connection, and what I think most of you are interested in on this call today, we're down here in this residential and somewhat to a degree in this non-residential yellow category, which still a very small percentage of the total amount being installed out there, but not insignificant in terms of the energy savings and the environmental impact that we're providing to residential home, farm owners, small business owners, those types of folks. So there's a lot of ways to do solar. Big solar is a good thing for the state. Small solar is also a good thing for the state. And we would expect these trends, at least on the bottom section here in this residential, non-residential area, to really continue showing growth over the next at least 2 to 5 years, I would say. We're certainly not at capacity in terms of how much solar our grid can handle and how much solar is really efficient and makes sense for people to do. So all that stuff is good. Part of the reason I bring this up is to just mention some of the policies that we have here in Minnesota that make solar very economically viable and make it easy or much less difficult for folks to engage with this technology. The primary one being our net energy metering policy. So what net metering means is that every utility here in the state of Minnesota is required to compensate customers for the energy they sell back during, let's say, afternoons in the summer months. They're required to compensate them at the same rate for that energy that gets sold back as they charge you. So here in Minnesota, what that means is that you're not ever in a position where your system is going to be producing too much energy that you're then selling back and you're not getting good value for. For example, some other states around us, Wisconsin, Iowa, and both of the Dakotas, they don't have a statewide net metering policy. So every utility does it slightly differently. Some utilities will give solar energy owners good value on the kilowatt hours they sell. Others don't. And so putting in a large system that's designed to cover your energy use over the full course of a year really doesn't make financial sense from a homeowner's perspective, because you're investing in a system and buying panels and putting in you know, considerable investment into this, and you're maybe not going to get a very good return on your investment, which we'll talk about some of the ways that we can avoid those not advantageous utilities with batteries, which is kind of why I bring it up. A lot of folks in those areas that don't have net metering policies like we do here in Minnesota are really seriously considering batteries, and there are several business cases for folks to really look into that seriously and consider adding a battery onto their solar system. So okay, just to show you guys a couple of projects that we've recently taken on or that we've recently completed here in Rochester. Again, I'm sure that most of you have seen these things around. If you drive around as much as I do, they're kind of going in all over the place. So that's what's kind of happening there, and the net metering is really enabling folks to do that. So here is a 5.1 kilowatt system that we did here in Rochester, very standard. One consistent array, pretty much completely south facing, and this was designed to offset, I believe, about 90 to 95% of this home's annual energy use. And you can tell that we didn't even fill up the entire roof, which that is pretty typical depending on your energy needs and what type of appliances and devices you have in your home. Hot tubs are really killers. It's really hard to offset how much electricity a hot tub uses, especially when the air temps are as cold as they are right now. So having an energy efficient home with appliances, insulation, windows and doors, high efficiency HVAC equipment, all of that stuff is still very important and very valued. And I'm assuming if you're on this call, you probably know more about all that stuff than I do, being that I know some of the audience out there is very involved in this, and Megan as well, I know, is very conscious of those types of systems and how buildings integrate all of those different pieces to come up with a desired result, such as a net zero home or ultra high efficient home with very low usage. All electric homes we're also seeing as a very popular option for people that are wanting to avoid, you know, having any fossil fuel on their property, whether it be natural gas or propane or anything else that you might come up with. So that is becoming much more popular. We are getting a lot more folks specifically that are building new that are asking those questions and are hoping to get as close to some of those goals and benchmarks as they possibly can. So couple more installs that we'll look at here, just kind of glide through these different types of systems residentially that are very common for us here, at least in Rochester, and some of the more urban settings that we get into, which we deal with a lot. A lot of homeowners are interested in doing this, along with farm and business owners out of town as well. Here's a big system in a new development that we just did, I don't know, about a year ago. You know, a little bit larger in size. Energy usage here was a little bit higher, so we ended up going with more panels and actually larger panels. And so the goal with this one, I believe, was to get a little bit over what their typical consumption is, something like 110 to 120% offset of their normal energy bills. So these folks, they went big, and that was the right thing for them based on their future at the property and based on their historical energy usage as well. So another example here of a nice new construction. I believe we're actually talking with the owner of this property in adding on additional solar as well. I guess he didn't quite think he got enough the first time, and I think he's planning on doing an add-on or adding an accessory structure in the back that we're potentially going to add on to as well. So that's an option for folks. It doesn't hurt you necessarily to go with something that is sized to your current capacity or your current load, and then you can definitely add on to these after the fact. So this project specifically, I know Megan knows, and you folks might have already seen a presentation about, but this was a net zero project that we did for a customer a few years back at this point. But their whole design, their you know, appliances from day one, this was set up as a net zero project. So that was one of their main goals with this, and we helped them out with the solar specifically, but there's lots of other things they did that integrated into the building that helped them achieve that result. Another residential here, this is a real big one, 16.5 kW in Rochester. You can just barely see over the ridge line of this roof that there's a pool back there. That's another pretty typical energy consumer that we see oftentimes with folks that have a pool installed, or they buy a house with a pool, and they're oftentimes very surprised at how much electricity it takes to keep that pool running. And so that's one of the things that we get involved with quite a bit, are folks with pools or hot tubs, or electric water heaters, in-floor heat, some of those different appliances that can be very efficient in terms of not losing energy. They do consume a fair bit of it. And so putting together a really good estimate as to how much the solar system is going to make comparative to how much energy the home is using is kind of our #1 priority when we're meeting with folks and looking to sign them up to do an installation with us. So another project here in Rochester, again, pretty standard, metal roof here over the gentleman's garage. This one was 120% specific to their energy usage, and I believe it's actually producing slightly more than that. So they've done some changes to their usage habits so that they're not consuming as much energy, and thus getting a little bit better return on their solar investment, which isn't a bad thing. So okay, so what we're going to look at here in the beginning is a relatively small system that we did over in Austin, Minnesota. Would have been almost 10 years ago, or maybe 8 years ago. This is one of the first systems that Solar Connection did. 3.3 kW, so that's 10 panels at 330 watts per panel. And it has one Solar Edge 3 kilowatt inverter, which we'll talk about what an inverter is and some of the different options when we get more into the battery section. So this is going to be just an illustration of what a straight grid tied system is, and then, like I said, at the middle of the end of this, we're going to go into kind of the batteries and how that all works. So to start off, I just wanted to go through some screens that the monitoring shows the homeowner or the installer as well. We have access to it. So these days, being that most things are connected to the internet so that you can see what they're doing on your phone, pretty much every solar system that we install comes with online monitoring, which is where all of these screens come from. So nowadays, if you wanted to look on your phone to see how much energy your solar system is producing on your house, whether you're in Rochester or in Florida or in Europe, you're able to in real time see what your energy system is doing, how much it's producing. Is there any issues with it? Is it throwing an error code or whatever the case may be? And so this image here is a pretty accurate representation of what most annual production curves look like. It loosely, simulates or represents a pretty standard bell curve, with the majority of the solar production happening in the summer months. May, June, July, and August specifically are when we typically see the most production over the full course of the year, being that the sun is really high in the sky. It's up for a lot of hours, and we oftentimes here in Minnesota have a lot of very blue sky sunny days with very little cloud cover, which is another factor that plays into why folks are doing solar here in Minnesota. We do, believe it or not, have a very good solar resource here, much better than in countries like Germany even. Germany has a lot more solar capacity than we have here in Minnesota, but they get about half as much sun as we do. So there is definitely a case to be made for putting it in here. And while we're not as efficient as, let's say, Southern California, we definitely get enough sun to be able to justify doing solar all the way up here at 35+ degrees of latitude. So again, this is an annual look at what this particular system in Austin produced in the year 2020. That was the most recent year that we have access to. Pretty much simulates a nice smooth bell curve, with the majority of energy being produced in those late spring, early summer months, which again is going to be discussed more in detail about the implications of that when we get into the batteries. So this is what every year since the system has been installed looks like. We got this one turned on in 2013, so it has been, installed and running and producing power for about, 8-9 years now. And you'll see that there is variability here year over year. So not every year is exactly the same. That has to do with weather. That has to do with one thing we saw last year specifically was the impact of the wildfires and the smoke that was in the air that just shaded out the sun a little bit more than it has historically. All of that factors into that seasonability or variability of what solar is going to produce year over year. However, if you look at the totals for the year, it is extremely consistent as to how much energy you can expect a solar installation to produce. So, you know, between 2014 and 2019, almost very little, if any, variability. And then 2020, we had a pretty good year with this one. There wasn't as much snow last winter and spring, and this system did better than it ever has last year. So that's definitely a good thing. And then this is just it's produced so far in 2021. Not a whole lot, being that we're still in the cold winter months where the panels are often covered in snow. So in the history of this system, this has produced a lifetime energy of 25,230 kilowatt hours, or 25.23 megawatt hours, which is one of the measurements that we take a look at, you know, usually every year or every 2 years, to make sure that the system is on track, that it's producing what it's supposed to be producing, and there aren't any problems. What that equates to for us here in the Midwest in terms of an environmental benefit is a reduction of CO2 emissions of 39,064 pounds, which is a considerable amount of CO2 emissions not going up into the atmosphere and contributing to climate change, which is obviously one of the main reasons that folks are interested in doing solar. And so that's one of the things that, when you have monitoring like this, it will track that over the life of a system. So you'll know what your impact is in terms of environmental benefits, basically for the life of the system, as long as your monitoring is working. So. Okay, so this is basically a visual of what the panel layout looks like on the monitoring. So with this particular system, you're able to see what every single panel is producing pretty much in real time. This number here, again, is illustrating how many megawatt hours each panel in this system has produced over its useful life. So this one produced 2,070 kilowatt hours, or 2.07 megawatt hours. You'll see that the numbers get smaller as you move your way over here to the right, and the reason for that is that the main house in this example, the customer put these panels on his garage. The main house is 2 stories versus the garage that's a single story. So these panels over here on the east side of the array, or the right side of the layout, are shaded pretty much every single morning as the sun is coming up by the house itself. So they produce a little bit less than the panels over here on the west side, but still very efficient and a good spot to have them in order to get a desired end result, which was maximizing the offset that this customer was able to achieve from their historical usage back in 2013, 2014, when they would have first met with them and sort of engaged them on how to do this and what we would recommend that they do. So this is what the physical layout looks like. Not every solar system that we install is capable of showing this, but the vast majority of the residential projects we do, this is the inverter system that we use, and you're able to see, again, pretty much in real time what every single panel is doing in your system, which is very cool for the techies of the world, which lots of our customers are. Most people, though, we find after a few months of having it, they don't hardly ever look at the monitoring because it's not really telling them anything that they don't know. As long as your electric bills are very low or potentially negative at the end of the month, your system is more than likely working as it should. And this is something that we actually oftentimes look at this monitoring more than most of our customers do, which is just kind of an interesting thing that we've learned over time. So this is a quick video showing what we call the playback feature, which the playback feature is kind of cool to basically watch the sun rise and set over the course of a day. I'm gonna hit play here and you guys can see the panels wake up and kind of peak their capacity right around noon or 1 o'clock in the afternoon, and then you'll watch them kind of go to sleep again as the sun sets in the west. So I'll play that one more time because it went by very quick, but you'll see that the panels over here on the right side are darker for longer than the ones on the west. That is basically, like I said before, the fact that the house itself is shading this corner of panels every morning as the sun comes up, and then, as you can tell, they all go to sleep and power down when the sun goes down. So another cool feature that the techies that we work with really like, but most people don't really engage with it all that frequently. So Okay, so that's kind of the high level background of solar, what it does, how we work with customers, and just how popular it's become in the recent years. One of the changes, which is the point of this presentation, that we've seen in the last maybe 2 to 3 years, I would say, is the adoption and the engagement of folks wanting to do battery storage. Battery storage is kind of the hot button topic in the renewable energy world right now. There is more than enough information out there about how important storage is going to be as a part of our energy future, not just here in the US, but all over the world. The current model of, having large centrally located power plants that distribute energy across a vast grid system is relatively inefficient in terms of them having to have backup generation or demand generation, such as the natural gas peaking plant here in Rochester, for example, or there's lots of other systems that are being implemented across the US. That's the one that we're using a lot here. The downside to that model is that a lot of those facilities sit idle for the vast majority of their life. So you're spending a lot of money to have capacity available when you need it. So hottest day in the summer when everybody's air conditioner is cranking, the utility has to be able to provide that power when it's needed. If they don't have the capacity, you go into a case of blackouts or brownouts, which is something that doesn't happen often, but when it does, it can be catastrophic. In the case of us here in Minnesota, a lot of utilities will experience peak demand on the coldest day in the winter as well, when they have their customers using a lot of electricity to heat their homes or run their furnaces, that kind of thing. And if your power is going in and out, or your power is completely out in the winter, it's a very big safety concern. So the ability for folks to not only produce their own power on site, but then store some of that power to be used to either offset a higher rate or provide them with backup power should the grid go down, is becoming more and more common. And we're having those discussions with, I would say most of the people that we meet with are interested in talking about batteries and how they work and what they cost and some of the details associated with it. Before I get into some of the system elements that you see up there on the screen now, I will kind of add on to this idea I mentioned earlier about net metering, which the reason that batteries are not a requirement for most of the customers that we work with is because of that net metering policy that we have here in Minnesota. So the point being that if you're getting full retail value or a relatively high rate for the amount of energy that you're selling back to the utility, whoever that may be, RPU, People's Co-op, Xcel Energy, whoever it is, they're required to compensate you at the same rate for that energy, whether or not you self-consume it or you sell it back to them, which is a very big reason why folks don't spend extra money on a battery system, because there isn't really much financial return on investment for you to put in a battery system that stores excess solar energy in it to be then used at a later time. Financially, right now, in most cases, there just isn't really a need for that, or there isn't a mechanism that incentivizes folks to spend the extra money to put in a battery system. So that's one of the hurdles that battery technology is going to have to overcome, is just the fact that here in Minnesota specifically, because of that net metering policy, there just isn't a lot of financial reasons for folks to do it. Now, the backup power aspect is very important. Lots of people are interested in doing backup power for when the grid does go down. Lots of folks are interested in new rate structures that are sort of trickling into this world a little bit. The example I use is RPU here in Rochester just recently announced a pilot program where customers can voluntarily elect into a time of use rate structure, which basically the way that works is they will sell you power at a low rate in the morning and at night, when demand on their system is low, but then starting at 12 o'clock, 1 o'clock, 2 o'clock in the afternoon, when their demand or the amount of energy they have to provide starts going up, they crank the rates up on you in order to incentivize you to use less power. Okay, what I tell people, or what I call this for folks that know, is California pricing. So if you live in any densely populated urban area in, let's say, California, you're mandatorily on this time of use rate structure, where if you can avoid buying power from the utility in the afternoon, it absolutely will affect how much you are paying that utility in a given billing cycle or in a given month. So that is a utility way of, again, changing your behavior so that you don't wash clothes at between 2 o'clock and 7 o'clock, or you don't charge up your electric vehicle in those hours, because the power that the utility has to provide during those peak hours is the most expensive power that they have to deliver. And the less that they need to have available in those hours, the better it's going to be, not only for the utility, but for all of the folks that are paying bills in that area, specifically if you're in a cooperative. Co-ops are not for profit. Whatever it costs them to operate to keep the lights on for all their customers is what they charge everybody. So the ability of the utility to reduce their peak demand in the afternoons specifically, the better it's going to be for everybody in that utility area, which that time of use thing that I mentioned is the best business case that we have for folks to do a battery with their solar installation. Okay, and the reason for that is, and we'll get into this in a minute, is these systems really, and the one we're going to talk about most with SolarEdge and LG Chem, they were designed to integrate with a time of use rate system from day one, basically. So what we're looking at here is not necessarily an off-grid system like a prepper or somebody with a cabin that's 5 miles away from the nearest power lines. That isn't what we're looking at here. These systems are designed to be installed on the grid. So when the grid is up and everybody's power is on and everything is normal, these systems will do the same thing as a normal grid-tied system will. If you're producing more power than you're consuming, you'll sell the excess back to them. If you're consuming more than your solar is producing, you're going to either pull from your battery or buy it from the utility like you normally would. Now, if you're on a time of use, we program that battery to discharge during those high rate hours so that you're not paying the 25 cents a kilowatt hour during peak. You're then pulling from stored battery energy that you produced with your solar in the morning hours. And we'll get into the details of that here in a little bit. So the system elements that we're talking about here with specifically the SolarEdge system, which is what we've done the most of, the main one is the battery itself, which you can see here in the lower left-hand corner. The one we're going to look at here is a battery from LG Chem. It's a subsidiary of LG, which most of you, I would imagine, are familiar with them or have appliances in your home. They make TVs, refrigerators, ovens, washing machines, dishwashers, all of those different things. But they also make batteries. Specifically, they do a lot of battery production for the electric vehicle market. So Chevy Bolts and Nissan Leafs, a lot of the batteries that have gone into those vehicles come from LG Chem. So they're a very big company in the industry, and they've done a lot of battery storage in the last 5 to 10 years. So the battery is number one. This stuff here in the middle, the panels up on this roof, the optimizers and the inverter, those are all pretty standard components with any solar installation that we would do. So we're not going to talk so much about those. We're going to try and keep it on battery backup. But the inverter is really important when you're talking about integration with a battery, let's say in the future. So if you're somebody that is building a new home or even doing it as a retrofit, and you don't necessarily want to pay the high cost for a battery today, that impacts what we're going to install if you have us just do a normal grid-tied system. And the reason for that is that this inverter if you want to do a battery at some point down the road, it's not going to just be an inverter. It's also going to be a battery charger. It's also going to be a smart interface that's going to tell the battery what to do and where to send power depending on how it's programmed. So one of the things that we run into quite frequently now are folks that had us put a solar system in 3, 5, 10 years ago even, that now, because of pricing and because of maybe they've had outages with their utility or whatever the reason, now they want us to add a battery in, which unfortunately can be cost prohibitive for a lot of folks, being that the inverter that they installed 3 years ago isn't battery ready or isn't really battery compliant. So we would have to, in most cases, remove that inverter and put in a new one that is set up to have a battery component associated with it. So one of the conversations we have with most people, again, because batteries are so popular now, it makes a lot of sense to plan ahead for that if you're the type of person that is at all interested in batteries now, because of, again, economies of scale and pricing. The cost on these batteries is coming down every day. And so while it might not be worth it to put it in today, 2 years from now, that could change. So an ounce of prevention is definitely a pound of cure when it comes to this stuff. And if you're interested in looking at solar, I would say anybody that you talk to from a reputable company will be able to have the conversation on batteries with you and some of the things you should be thinking about if that's something that that you're interested in doing down the road. So, okay. Like I said, LG Chem, that's the system that we're most familiar with and we've done the most of here in Rochester. The picture that you see there is a battery that we installed at a local environmental learning center here in Rochester called Quarry Hill. They have a meeting and event, kind of a wedding venue that they put in called Prairie House. They built it several years ago. We put solar on it, I believe, back in 2017 or 2018. And their goal with that project was to have a self-sustaining net zero building that they could have events and classes and different types of things that they do at Quarry Hill. The reason that the battery in this case was so important is because Quarry Hill is kind of a quasi government entity where they basically don't qualify for net metering the same way that a regular residential house would. And so in this example, they're not getting really any financial compensation for energy that gets sold back to the grid. And so having a battery installed where they can take some of their solar production from the morning hours to be used later on in the day and avoid selling power back to the grid, that is financially a good thing for them, as well as it also helps them achieve their goal of having a sustainably powered building and again, get as close to that net zero number as they possibly can. So here's the battery itself. They're wall mounted in most cases. Here in Minnesota, they do need to be mounted inside, which is one of the design considerations with pretty much any battery system that we would do. They do not hold up well in cold weather. So you definitely want to make sure that they're being installed in a climate controlled area. Lithium-ion batteries, for those of you that are in the building community, I would assume most of you on this call, I'm sure you're familiar with how lithium batteries in your drills and your saws and things don't work when they're cold. It's the exact same thing for any type of battery system that uses lithium chemistry, which is all the examples that we're going to talk about today. So definitely needs to be installed inside and very ideally very close to where your inverter and your main electrical panel are as well, which can be tricky in a lot of the new construction projects we're doing. Most houses being built these days do not spare any space in the mechanical room for future things like solar and batteries. It's usually very tight in those spaces nowadays. And so, you know, that's one of the things that if you're in the design phase and you're looking at building new, if batteries are something that you're confident are going to happen and you want to explore that option, one of the first things that we'll ask you is how much space is available in your mechanical room, because they do take up you know, in this example, quite a large footprint. That battery itself is about 2.5 feet wide and about 3 feet tall. They're not very thick. They're only about 6 inches thick off of the wall, so they don't take up a lot of square footage in terms of floor space, but they do require a pretty good chunk of wall, which again, if it's right next to your breaker panel, that's the best case scenario. So we'd like to plan ahead for that. So the battery chemistry that this battery uses is lithium ion. That's the same battery chemistry in most electric vehicles these days. We'll talk about the other chemistries that are available more towards the end. Total energy capacity in this battery is 9.8 kilowatt hours. So kilowatt hours is how your utility bills you. That's what the meter on the outside of your house is measuring all the time. 9.8 kilowatt hours is surprisingly not all that much energy. If you look at, let's say, a typical month's electric bill, you might be using 1,000 kilowatt hours, let's say, in a month. Well, 30 days a month, you do some quick math there. That tells you that most residential houses that we meet with people at to look at doing solar, most homes are using more than 10 kilowatt hours a day. Okay, so again, the theory behind these battery systems is not to take you off grid and eliminate your utility connection entirely. It's much more about storing energy to be used at a later time when rates change or when it is advantageous for you to not buy from the utility. And then the supplement that you get with doing that is a small amount of backup power in the event that the grid goes down. If and or when the grid does go down, you are able, in this case, to utilize the energy being produced by your solar panels. So you don't necessarily, you're not stuck with that 9.8 kilowatt hours of storage. If your system is producing energy, you know, let's say a power outage happens after a big windstorm in the summer, and the next day after a big storm is usually really bright and sunny. Whatever energy your panels are producing is going to be usable to you in the home. So you're not stuck with the 9.8 kilowatt hours, but it's one of those things that if you're interested in getting backup power in the event of a long-term outage, well, most outages in our area occur in the winter months with ice storms and things like that. It's not always a guarantee that your panels are going to be able to produce enough energy to cover your whole home's usage, which again is one of the considerations we look at when designing a system for folks. Every one of these that we do is custom, and making sure that the homeowner knows what to expect and what this actually is providing them in terms of value is the number one thing. These systems without batteries are not cheap. When you add in batteries, you really want to know what you're paying for, and that again is kind of a custom thing for each project that we work on. So max charge and discharge power, what that is that's basically saying how much energy can you put into and pull out of that battery to power your home in the event that there's no solar being generated, which 5 kW is 5,000 watts. Most of the appliances in a typical modern home are going to consume much less than that, with the exception of an electric dryer, an electric oven and range, an electric water heater, an electric, septic pump, or even a large sump pump in some cases can draw, a real significant amount of power for a very short duration. So that's another factor that goes into designing these systems is if you want your whole house to be backed up by your solar and battery system, that is not always practical in terms of the cost that it would take to do that. So a lot of folks that we work with that are doing batteries, what we actually do for them is we install a critical loads panel, which is very similar to a generator if you've ever done any research on those, where we would pull out specific emergency or critical loads from the main service panel and put them into a sub panel, which when the power goes out and the utility is down, only loads in your critical loads panel would be fed backup power. So like lights, a couple of outlets, your garage, oftentimes folks will have us do the garage so that the garage door opener works, security system, hardwired smoke detectors, some of those things that you know, when you do have a power outage that you absolutely want to have backed up no matter what, those are examples of what we call critical loads. Everything else, air conditioners, ovens, dryers, you know, if your power's out, there's really no sense in doing a load of laundry or drying your clothes, especially if you're on if you have an electric dryer. Regardless of if you have batteries or a generator, that just really wouldn't make any financial sense. So those are the considerations that we talk through with people, which again, the biggest benefit to doing batteries for folks here in Minnesota is that backup power that they provide in the event that the utility goes down. So this specific system, or the LG Chem battery, comes with a 10-year warranty. That's a really good warranty for, you know, something like this that would be used theoretically every day. And we're going to look at a couple of examples of customers we've done these systems for that are using their batteries on a daily basis. So having that 10-year warranty from the manufacturer is really important. Last consideration that we look at is the actual weight of these. So this battery pack itself weighs over 200 pounds. And so even though lithium-ion batteries are very energy dense, that's the reason that's what we use in electric cars to maximize range. Your number one concern, or one of the main concerns, is energy density. It's very similar to these systems, but it adds up quick. So, you know, putting a 200-some pound battery on the wall is you know, part of the process when we put these things in, and it takes about 3 of our installers to hoist that thing up and mount it on the wall. So weight considerations are also something to be conscious of. Not nearly as much as it used to be, though, with some of the old off-grid systems that have big, heavy lead acid batteries that you know, almost have to be brought in with a forklift. It used to be that there were some installations that you just couldn't physically get the batteries where they needed to go because of how big they are and how much they weigh. That's becoming much less of an issue these days with the advent of, again, lithium-ion batteries. So okay, here is a photo of, this is actually the Prairie House project that I mentioned before at Corey Hill. This is the inverter here, inverter slash battery charger, or hybrid inverter is what we call it. The solar panels on the roof are coming down through this conduit here and into the bottom half of this inverter. From here, there's a disconnect switch, which is what this is. And then this is where the top section here is what actually converts the power being made by the solar panels, which is direct current. The inverter converts that direct current into alternating current, which is what the utility is delivering to your home at any given time. So this is pretty typical of what it looks like. You can kind of see this is a pretty standard breaker panel system, or main electrical panel. Most people know kind of how big those are. The inverters, in this case, this is an older style one that they're getting smaller every day, which is another thing that the industry is kind of helping us out with in terms of just the physical size of this equipment, again, because of small mechanical rooms and other challenges that we run into. So this is very typical. And then on the other side of this wall is where that battery is installed. So just right on the other side of that wall. So again, getting the battery as close to the inverter as possible is also another design consideration to keep in mind. So okay, back to the monitoring. So this is an example of what the online monitoring interface looks like from a customer perspective. This is just a typical day of somebody that has a solar system on the roof and a battery system associated with it. What you're looking at here is basically the consumption of the home across the full 24-hour course of a given day. And this is in August, the 21st, I believe. So what you're seeing here is some sort of load, more than likely an air conditioner that is kicking on every, I'd say, about 45 minutes and running for, you know, maybe 15 minutes. So these peaks are very typical for you know, most homes, whether it be air conditioning load, whether it be, you know, a furnace kicking on and off, well pump, sump pump, any of those things that turn themselves on and off periodically will most typically appear as these kind of similarly shaped humps in your consumption. So this red section here on the morning and then also in the late afternoon, that is representing how much energy you are buying from the utility. Okay, so you'll see up here this red is called import. that import number is basically saying how much energy you purchased from the utility in this given day or this given 24-hour period, okay? Once you get here to about 7 o'clock, 7:30 in the morning, you see this blue line starting to rise. That is your solar system starting to produce energy, okay? So before 8 o'clock, most of the solar energy, or almost all of it, that was being produced was being self-consumed on site. That's basically saying the energy that the inverter is putting out is going directly to the home and is powering whatever loads are on the property at that given time, okay? Starting at about 8:15, you'll see that the solar production ramps up as the sun is coming up in the sky and that panels are producing more. The area of green is solar energy that's produced that is then exported. Okay, so that again is where, depending on what state you live in, depending on what utility area you're in, these kilowatt hours might have good value, they might not. The value of having a battery system installed is that more of this green area is able to be turned into blue area, basically, right? And so you're not selling power back, you're storing it in a battery to be used later in the day or in a future day, or whatever the case may be. In the case of this one specific day, 8.45 kilowatt hours were consumed from the batteries. So that is 8.45 kilowatt hours that this customer didn't have to buy from the utility. The other way of looking at it is it's 8.45 kilowatt hours that the customer didn't sell to the utility. And in this case, the value of what they would sell those kilowatt hours for is not very good. So it makes more sense for them to store it in a battery to be used later in the day. So that's basically what that screen looks like. This is not a standard screen that everybody that we work with has access to, because there is additional equipment that gets installed along with the battery that helps us determine where the energy is going. But it is something that can be very helpful for people, especially ones that have batteries, to kind of know what their system is doing, realize, you know, how valuable it is for them, and also, most importantly, making sure that everything is healthy and working the way that it should. So the different discharge modes that the battery systems have, this is the SolarEdge example, but most of the ones we're going to talk about here in a minute or two are very similar. The first mode is obviously off, no battery charging or discharging. That would be a mode that you know, most of our systems don't ever go into off mode, but if you were to go on vacation or something and you didn't want your battery operating, you know, when you weren't around, you could put it in off. The next mode, Chargex Spv, that is the most common mode that we have our system set to, where anytime there is excess PV power or photovoltaic, which is power coming from solar, it gets put into the battery until the battery is fully charged. After the battery is fully charged, then it would get exported to the utility. So that is choosing the battery as the primary. Once the battery is satisfied and it's at 100%, then any excess would get sold to the utility. The other ones are less common, but the bottom one there, maximize self-consumption, that's another mode that we will oftentimes put batteries in the case of the example we just looked at, where they want to maximize how much energy they produce on site and maximize how much of that energy they consume on site. And the main case for that is if you're in an area or utility that doesn't value the kilowatt hours that you sell back, that is the best mode for your system to be put into, which would have your battery operating basically every day. So every morning it's going to charge up. Once it hits 100%, it's going to go into a discharge mode, and it's going to discharge itself until it reaches a preset, what's called depth of discharge, which is basically the battery's way of protecting itself. You don't want to run these batteries down to 0% life, because that will shorten the amount of years that the battery is viable for. So all that stuff we take care of for people, but there's lots of considerations that go into designing these so that you have a system that lasts a long time, but also provides the value that you're looking to get out of it. So All right, so that was the first system. That's the one that's most common. I didn't mention this before, but that is a very, very similar system to what you may have read about or heard about in the news with the Tesla Powerwall. The Tesla Powerwall and the LG Chem battery we just looked at are essentially the same thing. So if you ever, hear or see a video or read an article about Tesla Powerwalls, that's pretty much what we just talked about. And there's subtle differences there, but the one that we use, because we're not a certified Tesla installer, is the LG Chem, which is, again, very common. Lots of companies doing solar, that's their primary go-to solution for folks that want to do batteries. So the next system that we have a little bit of experience with, we just did our first one here last year, comes from a company called Enphase. Enphase is another manufacturer of solar inverters. They do things a little bit differently than SolarEdge does in that microinverters or Enphase microinverters, basically there's a little device on the backside of every panel that converts the electricity from direct current, which is what panels make, into alternating current right on the roof. So each and every panel has its own inverter where that conversion to AC is happening on the roof, and AC power, same as what's powering your outlets and your appliances now, is what comes down off of the roof and then hooks into your main electrical service. So just a little bit different way of doing it. Both SolarEdge and Enphase are very big companies, at least here in the residential solar market in the United States. Enphase, I believe, just surpassed SolarEdge with total capacity, so Enphase is gaining in popularity. We work with both of them. I would say historically our favorite has been SolarEdge because they're more reliable. We've had less issues with failure on them over our 10 years being in business. But Enphase is also a very good company that we're working with more and more as their technology improves and their reliability improves. So what you're looking at here is very similar to what we looked at before. Again, just a slightly different way of doing it. Battery specs are a little bit different in terms of how much energy can be stored in these systems, how much energy can be used at any given time. Some of the benefit of the Enphase system is again, with the microinverters on the roof, it can definitely simplify the interconnection, being that it's all AC power once it comes down from the panels. This system is a little bit more expensive for the amount of energy that you get to use at the end of the day, which is one of the factors that is kind of prohibitive in going with something like this. But this is a perfectly viable option that I think is going to be very common in the California's markets, Florida, California, some of those really sunny places, being that Enphase is companies have been installing with it in those areas for many years, and so retrofitting a system like this in is going to be easier for folks that have already gotten a system installed using Enphase microinverters specifically. So 10-year warranty with these batteries as well, and you can see that these this particular system with the cabinet and the battery modules that go with it weighs over 300 pounds. So still quite heavy, but not nearly as bad as some of the old lead acid battery systems that folks used to do, back 5 years ago. So, okay, so this is another graph that comes from the online monitoring. This one again is coming from Enphase, so it looks a little bit different, but basically what you can see here in these blue lines is how much energy the solar system made. You can see again it caps out at about solar noon every day, depending on the weather and cloud cover and whatnot. So the solar production there is in blue, and then this jagged up and down chart here in this red, that's what the property is consuming as a whole. So this is basically measuring in real time how much energy is being consumed by the house. In this customer's example, he actually has his batteries turned off, where the only value that his batteries are really providing right now is backup power in the event that the grid goes down, which if and when the grid does go down, this system will sense that. It will automatically isolate from the grid to prevent backfeeding, and it will power up, it'll power itself up, and it'll run the critical loads panel that we installed basically off of his solar production and the battery storage that he has installed on site. In terms of production, in this case, this system on the 16th or on the 15th of February produced 8.84 kilowatt hours. The property itself consumed 16.26. So his solar system offset about half of what his property consumed just on that one day. So this is a pretty big system, but also has a pretty big house that it's installed on. So they use quite a bit of energy in a typical day, especially in the winter. They've got some electric heating loads that consumes quite a bit of energy. So, all right, another option that we have in terms of a battery storage system comes from Generac. Their system is called the Power Cell, also a lithium-ion battery system. Their system is designed to be more modular, so the tall piece of equipment you see here on the right side of the screen is basically like a server rack, if you're familiar with that, or it's just a compartment where you can slide in as many battery modules as you decide to purchase. So we would install, you know, the cabinet itself and the inverter system and hook it up to the solar like we normally would. And then you would be free to add on battery capacity as your needs changed, or as you get more comfortable with the system and you want it to provide a little bit more hours of backup or provide a little bit more horsepower to get your air conditioner started or what have you. This is a really good option if you want to get a system installed, take advantage of the tax credit while it's still around, and then save money on batteries until you know how many you might need or how many you might want to buy. So you know, again, it's a little bit variable with how much power you can get out of these and how much you can store with these. But the nice thing about this system, or one of the nice things, is it's coming from Generac. They're a very big name in the backup power world. Solar Connection is actually a Generac dealer, so we can acquire and install any Generac branded product out there. Which is one of the reasons that we offer this to folks. We also do traditional internal combustion generators as well for a lot of folks, which is a little contrary to our environmental goals here as a company. Obviously, we take very seriously the concerns of carbon emissions and all of that. But at the end of the day, a standby generator oftentimes is the right decision for a lot of folks that are looking for reliable 99.9% of the time I'm going to have power if the grid does in fact go down, whether it be in the middle of winter, the middle of summer, whether the sun is shining or not. If you're someone that has, let's say, a medical device or some very absolute need to have power all the time, no matter what type situation, a standby generator fueled from propane or natural gas, if you're in town, is a really, really, really good option, because they are very reliable, and again, in the case of someone in town that has natural gas, it will run as long as that gas is being supplied to it. So that is one of the cases that you know, battery technology still has to mature quite a bit in order to truly compete with a typical automatic transfer, automatic start generator like Generac and other companies have been doing for many years. So the nice thing about it, though, this particular system is that it does integrate with generators. So if you did put in a Generac Power Cell system and you put in a traditional, you know, gas or propane or natural gas fired generator, that generator will plug into this system and will charge the batteries for you in the event that the grid goes down and solar isn't producing enough to keep the batteries charged. It will automatically tell the generator to start up and produce power to charge the batteries up, which is one of the very neat things about this system, which is very useful for some folks. If you're way out of town and you're the last property at the end of the line and you have frequent outages or long duration outages in the event of like storm damage and things, we had some folks around Rochester, I'm sure some of you folks on here know that storm a couple years ago. You know, we had people that were out for, you know, over a week in some cases before the utility was able to restore power. So having those options is really the most important thing when you are in a position like that. You know, if your power goes out for a week in the middle of winter, you're not just worried about your pipes freezing. You're not just worried about, you know, the food going bad in the fridge. You're worried about your safety, because at that point, you know, temperatures like we've had this week are absolutely deadly, and having those redundant systems that will provide you backup power in the event that there's a long-term outage is more and more important for folks, not just here in Minnesota, but certainly on the coasts with the fires in California and the hurricanes on the East Coast. People are very interested in having these redundant systems that will allow them to at least maintain their ability to stay in their homes and kind of weather these storms that seem to be more and more frequent. So Generac also a very good option. Probably the most expensive of all of them, unfortunately. Part of that brand recognition and that brand name is part of what you pay for, but certainly is within the range of what people are looking to spend for what they would get out of it. So the last piece of equipment, or the last inverter technology that I'll talk about here, is called SolArc. They're a relatively new inverter manufacturer based out of Texas. They kind of got their start in the military world. And what this system is it is a hybrid battery inverter where you can plug basically any battery system that you want to use will integrate with this inverter. So the first system I went through with Solar Edge and LG Chem, the only two battery options that work with that system are LG Chem and the Tesla Powerwall. The only batteries that work with the Generac Power Cell system are the Generac Power Cell batteries. The SolArc inverter is battery agnostic, meaning you theoretically could go to Walmart and buy 12 deep cycle trolling boat or trolling motor batteries or RV batteries, deep cycle batteries, wire them together to achieve a system of 48 volts. And this inverter would intelligently charge them and utilize them in the event of a grid outage or whatever you have it set up to do. And you have the freedom to use any battery manufacturer that you want. So that's one of the nice things with the SolArc. It also has a generator input similar to the Generac system I mentioned just a minute ago, and it has a very high discharge power ability. So you can run, in the case of this SolArc, you can run well pumps, you can run air conditioners, you can run some of those large loads off of this inverter that some of the other systems just aren't robust enough to be able to kick off some of those large appliances. So also has a 10-year warranty, very user friendly. I did a quick screenshot of their user interface screen here, which most of the interaction that a homeowner would have with this particular inverter is going to be on this main screen right here. And you'll see what it's trying to demonstrate. It's saying, here's how much solar energy is coming in via the panels. Here's how much is going in or coming in from the grid. Here's how much your property is consuming. And then here's the state of your battery system, or the state of charge in terms of voltage, and then how many kilowatt hours have been consumed in a given day. So this system is really intuitive. It does solve a lot of the problems that some of the other systems have in terms of, like I mentioned, being battery agnostic. That's a huge one, where if you wanted to scale your battery system into the future, buy 2 batteries now and then add 2 to it every several years, those other systems that I went over in the beginning are not great solutions for that, versus a system like this, which is really designed for people that want to scale up their system over time, or they don't want to, paint themselves into a corner in terms of what battery chemistry they use or what company they buy those batteries from. If you put one of these systems in, whatever batteries are in 5 years, 10 years, 20 years, this will be able to work with those, which is the whole concept behind this design, is to keep the battery side of things as flexible as possible. Same deal as most, 10-year warranty standard from the manufacturer on this inverter, and then the batteries themselves would come with a warranty from the manufacturer of the battery system that you decided to choose. So okay, I rambled on this entire time. I hope that that wasn't too dry for some of you out there. Megan, do we have any questions on the chat, or do we want to just open it up for folks to just ask those questions?
We do not have any questions in the chat. I was thinking it would be nice for you to drop your email address into the chat if anyone wanted to reach out to you directly with questions to follow up. Otherwise, feel free to drop them in right now. Otherwise, thank you everyone for attending. And thank you, Chris.
All right, no questions. Sounds good. For those of you out there, please, if you have any questions on this, feel free to reach out to me. I put my email in the chat, but you can get a hold of us at our office here in Rochester. You can stop in if you're interested in doing that. Send us an email via our website if you're looking for some more information. And we're here to help answer questions. There's always more questions than there seems to be answers with any of these new technologies and new things that are kind of coming on the scene, but we're here to help, and we absolutely want to support anybody that is interested in at least looking at this, whether it's a new construction, whether it's a retrofit or a remodel. We're here to help fill in the blanks, being that you guys, especially builders out there, are not experts in this stuff. So if you do have somebody you're working with that fits the bill for somebody that's interested in looking at solar or battery backup or whatever it may be, please don't hesitate to either reach out to us directly, or anytime that we get a referral from somebody, we absolutely love that. We rely on that as a small business, like most places do. So please send them our way, and hopefully we can make something work for them. So
all right, thank you everyone.
Thank you.